I would now like to welcome to the conference Vikrant Pratap from Qualus, who's going to talk to us about the practicalities of handling polymer spheres in full-scale production. Thank you very much. Good morning.
Thank you for inviting me to present at this event. This is the second time I've been invited to participate here, and both times I always have mixed feelings. On the first hand, I always feel incredibly honored that there's interest in this community to learn about what we're doing in our technology. But on the other side, I always have a bit of imposter syndrome because we don't offer any sophisticated chemistry, and what we offer is a mechanical solution. But hopefully you will find some value in what we have to say here today. So I'll be talking about the practicalities of handling polymer spheres in full-scale production. And before getting into that, it helps to put that into context. Why consider polymer spheres at all? What's the value of polymer spheres to consider them for the production process? So polymer spheres are small polymer-based pellets that help to improve the retanning process by reducing water, chemistry, and time for the retanning process. And the way they do that is in the retanning drum, we replace large quantities of water with polymer spheres that help to enhance the mechanical action inside the drum. So the drum, if you will, creates a macro level mechanical action, and the polymer spheres enhance or complement that macro level mechanical action with a micro level mechanical action that helps to drive the chemistry more deeply and uniformly into the fiber structure of the hides. Now, what are the benefits of that? Number one, of course, because you're replacing the water required for the production process can be reduced typically in the range of 30 to 40% for the retanning process. Number two, the chemicals required for the production process can also be reduced because more of the chemistry is ending up in the fiber structure of the hides, less comes out as waste. So the chemistry doesn't change. Whatever the standard formulation is for a particular tannery, for a particular article, it stays the same. But the dosing, the quantities of chemicals that are required for the production process can be reduced because they're ending up where they're intended to go and less coming out as waste in the effluent. Previously, it was demonstrated that the typical reduction in chemistry in the retanning process, so this is for retanning agents, fat liquors, and dyes, is between 10 to 15%. Over the last year or so, through the work that's being done with tanneries around the globe, that figure has consistently gone up in the range of, to be now in the range of 15 to 20% reduction of those chemicals. There's a slight, obviously it varies from recipe to recipe and for different chemicals, particularly for waterproof articles. For the silicone, the reductions aren't quite as high, but nevertheless, for most of those chemicals, they can be reduced in that range. And then the third thing that's been demonstrated over the last 12 months or so is the opportunity to reduce the time for the retanning cycle. And that ranges from 20 to 30% reduction. We've seen that in different tanneries from both for the footwear and the automotive side. So what's the benefit to tanneries from having these reductions? First, of course, the environmental benefits. The application of polymer spheres for the reduction process reduces those core inputs, and that aligns very well with United Nations Sustainable Development Goals, for them. Number 6 rather, clean water and sanitation. Number 9, industry, innovation, infrastructure. Number 12, responsible consumption, production. And number 3, climate action as well. There's an opportunity to reduce the carbon footprint. If you're turning the drum for a shorter period of time, the energy required for the drum is reduced. If you're reducing the effluent content, the energy required for the effluent treatment is also introduced. So significant environmental benefits. But as we all know, environmental benefits are not enough to drive the adoption of a new system or a new technology. There has to be a commercial incentive for tanneries as well, and that's really what appeals to tanners. And through the chemical savings alone, the tanneries see potential to reduce their chemical costs, typically in the range of 2.5 to 5 US cents per square foot of leather. So that's why the technology is being considered. But it's one thing to say the technology works in a small scale. It's another thing to actually have it applicable at large scale, industrial scale production. And that's what I'm going to focus the rest of this talk on. So what's required to enable the technology to be adopted at production scale? Number one, there have to be simple solutions for handling the spheres. So the switch to a new production process can't itself be overly cumbersome. Number two, because it's a new input into the production process, one of the concerns, of course, is the containment of the spheres. Will the spheres just end up all over the tannery floor? Will they end up in the drains and cause an operational nightmare for production? So the containment of the spheres has to be effective. Number three, the time for the handling of the spheres has to be manageable. So we can't have a production process that now requires 20, 30, 40% more time because of this new input that's going into the process. And number four, space. So there has to be space within the tannery to incorporate this new input into the production process. And that's particularly an issue, of course, here in Europe, but not only in Europe. I think most tanneries that we've been to struggle with that challenge. So it's one thing to say that those benefits that we talked about on the previous slide can be delivered. It's another thing to say they can be delivered in a practical way that is manageable for tanneries and attractive for tanneries. And so how can that be done? So the way to go about that is to offer a solution that's very modular for tanneries. So they can configure the key elements or the key modules to their specific needs. And those are, number one, a very straightforward way of storing the spheres. Number two, a straightforward way or simple way of dosing them into the drum. Three, once they're in the drum, containing them inside the drum. And four, at the end of the process, when the drum contents are emptied, separating the spheres from the leather in a way that the spheres can be moved on for the cleaning and the hides can move on for the natural the next step in the production process. So module one, how is the storing and dosing done? The solutions that are now offered and available or being used in tanneries are actually pretty basic. Over the last few years, tanneries considered a broad range of solutions. So automated solutions being pumped with water, being pumped with air throughout the tannery. And time after time, case after case, what the tanneries seem to have found is that it's just easier and simpler to use a manual solution. You load the spheres into a hopper similar to the one that you see on the screen, on the left-hand side of the screen, and you position that in front of the drum, and then you open a valve and load it into the drum. So there's an example of this. Hopefully the video will play. I've blocked out a couple of areas here just to respect confidentiality within the tanneries where these images and videos are from. But what you see here is the operator essentially positioning that container in front of the drum, and then this slide or this chute, the length of that can be adjusted. The operator opens a valve over here, and the spheres, the orange flow that you see there, just goes inside the drum. In this particular example here, you see that being done from the mezzanine, but that solution here can also be applied via forklift if there's front loading of the drums, not from a mezzanine, but from the front side, from the floor. And the process for loading the drums typically takes about 2 to 3 minutes for 1 ton of spheres. And that figure is critical because the ratio of spheres required inside the drum is 80% by weight to the wet blue. So if you have 1 ton of wet blue going inside a drum, you need 800 kilograms of spheres going inside the drum. For the automotive loads that we see typically between 2 to 3 tons that we see particularly in Mexico and in Brazil, you need about 2 to 3 tons of wet blue. You need about 2 to 2.5 tons of spheres going inside the drum. And what that means is typically the spheres can be loaded within about 5 to 6 minutes for a full production scale batch. So that's one element of making this practical. So it's not just deploying in a small scale R&D environment, but a full scale production environment. The next element, so those containers that we showed on the previous slide, they act as the storage vesicle and the dosing vesicle inside the drum. The next key thing is containing the spheres inside the drum. So typically a production drum will have washboards that have holes that are about an inch or so in diameter. Now the spheres being about the size of a garden pea or a grain of corn will of course flow through as you're changing bath after bath after bath. And there's a very simple change that can be made to the inside of the drum to contain the spheres. So you see some examples here of changes that have been made at tanneries where the washboards have just been replaced. In some cases, those washboards, the new washboards have been manufactured by the original drum manufacturer and actually been installed by the original drum manufacturer. In other cases, the tanneries prefer to source locally from their own base of suppliers. Particularly, that seems to be the case. Well, we've seen that in all markets, really. It's really a relatively straightforward and basic change that can be adopted in a tannery without significant downtime in production. So that change to a drum typically takes between a day to a day and a half. And one of the concerns that came up when this system was first explored in a tannery was, what does this do to the drainage time? When you change the size of the holes in the washboards, will the drainage time be significantly increased? And the answer to that is no, because the overall surface area of the openings with this design is actually greater than with the standard profile of a washboard. So even though the individual slot or hole is smaller than a typical washboard, the overall set of openings, and it has a greater surface area, and you don't get a reduction in the time, the drainage time, and that's really key because we don't want to have a benefit in one dimension and have a downside in another dimension. And then for separating the spheres from the hides at the end. Now, let me just describe what you see here in the pictures over here. So here what you have is a full-scale production drum of about 3 tons of wet glue in a typical production batch. This is an automotive example. And the mechanisms for containing the spheres are actually fairly straightforward and fairly basic. So you have a standard skip underneath. All that's being done here is a shield of a sort that's being put in place. That can be stainless steel, that can be polypropylene. In this particular tannery over here, it's not even a shield, it's a curtain that they use, and it's just aligning the different, and then putting some side bearers on that so that as the drum is opened and it's emptied, the contents of the drum are channeled much more effectively into the skip rather than overflowing to the side. Simple, basic solution. There's a similar sort of mechanism on the back of the drum. And you see in the picture here, you've got roughly about 2.5 tons of hides or coming out of the process, wet, mixed in with spheres in that skip, and there are spheres on the floor. Now, as with any solution, right, getting to 100% containment is achievable, but there's a cost. Right, so it's for the tanneries to decide what works for their particular production environment. But in this particular example here, we certainly see 99.9% containment of spheres. So with a typical automotive batch that we would see where you're seeing production levels of 2.5 to 3 tons, let's say 2.5 tons of wet glue, and you have 2 tons of spheres going into the production process, what you're getting is about 2 kilos. Out of that 2,000 kilos, about 2 kilos that are not contained. That needs to be tidied up. The operators can then tidy that up with a vacuum or with just a basic broom, and it takes a few minutes. So it doesn't create an operational headache for the tanneries. And then the final operational constraint, of course, is space. Now, this image here that you see is one of the first deployments of a solution at a tannery. And that contains, that blue box that you see on the screen is a 40-foot shipping container, right? That contains a cleaning machine, cleaning system that contains the sphere, cleans the spheres after each use, and then they're put back into the silo over here for recycling or reuse day after day after day. Now, that is only feasible in tanneries where they have that particular space available. Not all tanneries do, and even if they do have that space, it may not work well with their production flow. So how does this become practical for a tannery? And the answer to that is, we need to, whenever a new technology is brought to the industry, we need to find a way to enable the customers or the tanneries in this case to focus on their core business and not be burdened with the operations of new activities. And a simple solution's been developed there as well, where the tanneries don't need to incorporate this cleaning machine on site at their tannery anymore. They get a daily shipment of spears, and they use the spears when they're done and they come out of the process, they're collected and they're cleaned off site, so the space is a non-issue. So over the last few years, tanneries, I'd love to say that we had developed all these solutions. Actually, the tanneries have taken a very large step in developing a lot of these solutions themselves to start working with spheres, which is great. So we are starting to see more and more interest in starting to use this technology in Asia, in Mexico, in Brazil, not yet in Europe, but we think European tanneries will certainly start to move in that direction over the next couple of years. And so the solutions are there. The solutions for adopting a new technology, not just this, but the solutions for adopting, the solutions for making the tanning process or the retanning process or leather production process in general more sustainable, more environmentally friendly, more streamlined and lower costs are there. What's missing at the moment is that mindset to adopt a new technology and that willingness to change. And I'll share with you some of the questions that come our way, and the questions reflect a fear of change rather than a real constraint that exists in the system at the moment. So the types of questions or concerns that tanners still have, despite the technologies being available for many years, is our leather's unique, right? It won't work for us, right? Well, it works for Wolverine, it works for Timberland, it works for Echo, it works for BMW, it works for Gucci leather, it works for Louis Vuitton, it works for a broad host of leathers. But there's still that concern that, you know, what we have is so unique that it won't work. And I think it's important for anybody bringing in new technology, whether from academia or from the commercial industry, to demonstrate that. And that does, you know, require commitment on the side of the tannery and on the side of whether it's people in academia or in industry to demonstrate that until there's comfort level there. And that's starting to change. The second concern then comes around okay, so we believe it works, but is it practical, right? And as we've just demonstrated over the past few slides, it is practical because there are tanneries now that are using it in full-scale production in Mexico, in Brazil, in India. If it works for a small tannery in India that's doing 500,000 square feet a month, and it works for an automotive tannery in Brazil that is doing, you know, in one drum, 3 tons per drum, and they've got, you know, on a daily production level, about 24 tons of wet blue being produced in or retanned into crust. And you've got that, yeah, it works, right? So there are more and more proof points, and that will help to overcome some of the inertia that exists in the industry. And then there are objections around, you know, is it costly, right? And I don't want to get into too much of the commercials here for obvious reasons, but the commercial case for tanneries has to be strong, and it's becoming commercially viable. It is commercially viable for tanneries, but the fundamental problem is still one of mindset, right? It's like what we've often experienced, whether ourselves or people that we know. We want to make a change, right? We want to become healthy. We say we want to lose 20 kilos, run a marathon the next year, but we don't want to go to the gym and we don't want to change our diet. We still want to eat our donuts and cakes and ice creams. Until we commit to that change, that's not really going to be possible. So it's not a matter of technology now, it's a matter of mindset for the industry to take that step forward. And why is that important? Because our industry is faced with challenges, multiple challenges that are existential, I believe, right? One challenge is from, and I think all of them are well-intentioned and well-meaning, right? One challenge is certainly a push towards sustainability, right? And whether that's coming from brands, whether that's coming from consumers, there is a demand on this industry to demonstrate that it is sustainable or can be more sustainable than it has been in the past. If we don't respond to that, we will die, I believe, as an industry. That's just what's required of us today. And then the second threat to this industry comes from alternative materials. And you know, I don't need to tell this group, you know, whether those claims are real or not. I personally believe a lot of those claims are overhyped. I think there's a lot of data to support that, but it doesn't matter. It doesn't matter if those claims are overhyped because they're there, they're being believed by a lot of consumers, they're being believed by a lot of brands, and the onus is on the industry to say, there are technologies out there, and we are better, our product is better. Leather is a fantastic, unique product that is unparalleled and cannot be matched by alternatives. But we still have a responsibility to not only get that message out there, but also to make it better in terms of how we actually produce that particular product. And I'd like to just leave you with a quote from Charles Darwin. It is not the strongest of the species that survives, not the most intelligent. It is the one most adaptable to change. And I think the work that's being done in the industry, whether it's by LWG or Sustainable Leather Foundation, is really critical to driving that change. But we must change. We must respond to these external threats and not be caught in a bubble insisting that we are better yet we are better in many ways. But we need to continue to improve and get better. There are many technologies out there, I believe, that allow us to move in that direction. Polymer spheres is one of them, but it's not the only one. And I think we have a responsibility to bring these to market. Thank you.
We'll have time for a quick question, if anyone's got any questions.
John? So, as your Vikrant, your figures for the water savings, does that include also the water usage presumably used in cleaning up the spheres? Or is that extra?
That's a net figure, including the water use. Yes, right.
Thank you very much. Thank you. Lovely.
William Wise from University of Northampton. Do you or have you done any sort of sustainability metrics, things like carbon footprint, on how the spheres compare with traditional water use, including the water processing the other side as well to clean it up? So
we have done that internally. We haven't done that externally. And one of the key, we have done a carbon footprint analysis, and it's not just the water that you need to consider. Water usage is also the reduction in the chemical usage and the carbon footprint associated with that 15 to 20% chemical usage. So when you do, when you look at all those different factors, yes, there's a significant reduction in the carbon footprint.
Bob Rees, TfL. You mentioned these spheres about pea size, but that's when they're new. They will weigh, and they will also weigh drum walls. What's the impact on the life of a drum? What's the impact on these spheres becoming smaller and smaller that will affect the draining in time?
Sure. Really good question, because we've done tests on that. Because from purely from a values perspective, we're not a company that wants to promote a sustainability benefit on one dimension and have a detriment on the other. So before we started introducing this for trials in tanneries. In fact, we did a lot of work with the University of Northampton to understand the wear and the use of the spheres over time, right? And we did very extreme tests in drums at the University of Northampton that under very extreme conditions showed that they could easily be used for 500 to 600 cycles before there was a significant reduction in the size of the spheres that they would have to be replaced. Now, when I say that was extreme test, that was without any significant water or hides in the drums. It was really putting them through the ringer, if you will. In practice, what we're finding in the field is 500 to 600 cycles is a huge underestimation. So the abrasion on the spheres is minimal, even after 3 to 4 years of, well, 3 years I can say of being used, because tanneries haven't been using them for 4 or 5 years. It's a relatively new technology. So that's number one. The second question that you had, the second part of your question was the impact on the drums, right? And again, the initial work that we did on that was theoretical. We conducted it here at the University of Northampton. And that work showed that there isn't a detrimental impact on the structure of the drum or the wearing of the drums. In fact, the one impact it does have on the drum, particularly it tends to be on the wooden drum, is over time you will see a buildup of chemicals inside of a wooden drum. And what the spheres actually do is they scrape off that layer of residual chemical that builds up on the drum. So it actually cleans the drums. And what we have found with both wooden and polypropylene drums over the past few years is that there's no impact on the life cycle of the drum. Now, having said that, we don't have 20 years worth of data from a full life cycle of a drum. So the data that we do have is 3 to 4 years worth of data based on actual practical implementation.
But you are confirming there is abrasion cleaning the drum, but on wooden drums, I just throw into the room, I don't know.
Sure.
There will be wear on the wood itself, especially when we're talking something like 18 tons pressing on those pellets. By comparison to the
Sure.
100 kilograms you have in the drums here.
So we've done tests on that. In fact, the tanneries that we've worked with have also done tests on that. So I'll give you an example from a Brazilian tannery that was concerned about this particular topic. And what they did was they ran 2 drums, one with spheres, full-scale production, and they do, it's an automotive and furniture tannery. They do about 2.5 to 3 tons of wet glue per cycle inside that drum, right? And they, and on top of that, you have obviously the water, chemicals, but then you also have the spheres inside. And what they found was they did a very systematic control test between one drum that was using the spheres and one that was not. And over time, they did not, from their empirical results, they did not find any impact on the abrasion inside the drum.
Thank you very much.
Sure.